MDSJ Process Emission Control System. 400 ton per day fluidized bed sludge incineration and energy production plant. (22 to 26% dry, dewatered sludge at decanter coming from treatment and WWTPs gets dumped into underground bunkers. Progressive cavity pumps, located below the bunkers, convey the sludge to the above-ground intermediate silos. The sludge pumped from the underground bunkers is stored in above-ground silos. The progressive cavity pumps, installed below these silos, convey the sludge to the fluidized bed incinerator. Air from the fluidizing air blower is heated up to 588 degrees Celsius by a preheat heat exchanger and primary heat exchanger utilizing heat from the flue gas. The hot air is sent to the incinerator for combustion and fluidizing the sand bed. The sludge, with a 3,600 kilocalorie per kilogram heat value, mixes with this hot fluidized sand bed, and combustion air is burned completely in 5 seconds at 868 degrees Celsius and is converted into inert ash and flue gas. Hot flue gases leaving the incinerator first go through a primary heat exchanger, and the fluidizing air coming from the air blowers is heated up to 588 degrees Celsius. This way, the continuity of the combustion is established. After leaving the primary heat exchanger, the flue gas temperature is reduced to 658 degrees Celsius. The heat of the flue gas is then utilized by a waste heat boiler to produce 12 tons of steam per hour at high pressure and 450 degrees Celsius. High pressure and superheated steam at 455 degrees Celsius generated from the waste heat boilers is sent to a steam turbine to generate electricity. Flue gas containing dust and particulates from the waste heat boiler goes through a series of multicyclones for particulate reduction. The removal of hazardous materials present in the flue gas, such as mercury, dioxins and furans, is achieved by the injection of active carbon after the multicyclones. In addition to active carbon, lime is also injected to remove acidic compounds such as SO2. Coarse particulates and ashes collected by keeping in cyclones are stored at the silos with the help of densport, also known as dense phase pneumatic conveyor. In the case of an increase of the pressure at the conduit pipe, air is automatically injected from the boosters located on the pipeline, and the transportation pressure gets decreased. Depending on the differential pressure that may occur because of the congestion at the baghouse filter over time, cleaning is made with an air jet. During the cleaning of the congested filter chamber, other filter chambers continue the purification without interrupting the system. The wastes produced from the house bag filter are transported to an ash silo with the help of densporter. Gas purified of the dust from the jet pulse filter gets transported into a wet scrubber. SO2 removal is established with the help of closed-cycle water pumps located on the scrubber by showering the gas from above with the added chemical fluids. For the removal of the NOxes in the gas, urea dosing is used at the incinerator stage. There is an induced draft fan in the system that pulls the flue gas. Clean gas coming out of the system is released into the atmosphere with the help of an adequately high chimney. The emission values of the flue gas are monitored by a continuous emission monitoring system. Sectors. Industrial dust control. Jet pulse filter. Gas and odor removal. Chemical wet scrubber. Activated carbon absorber. NOx SCR, SNCR. Pneumatic conveying. Dense phase, dilute phase. Industrial vacuum cleaner. Incineration plant. Coal plant. Cement company. Steel company. Glass industrials. Chemical industry. Fertilizer, detergent, paint. Treatment facilities. MDSJ